Hey everyone, welcome back. So my name's Rob, and this is a class on an introduction to statistics for the psychological sciences. This is the second lecture of the course, and this is the fourth and final part of this second lecture. I know this has been a long lecture. It's longer than most will be. We had a lot of material to cover in a short period of time. So thank you for making it this far. Let's just dive right in. We're going to talk about levels of measurement, how different ways, different properties of how variables are measured, and we'll talk about the upper and lower real limits of continuous variables and how to compute them. So the first main way that you can distinguish types of data is whether it's qualitative or quantitative. So quantitative data, which is what we typically think about when we think of data, right, is a quantity or an amount or a count. It's something that we typically can do math on. We can add it up, like feet as a measure of distance, or frequency, or weight, or age. If someone who is 10 years old is half the age of someone who is 20 years old, we can do division on it, right? So quantitative variable represents a quantity or an amount. Qualitative variables, on the other hand, reflect some kind of category or class. It's like we assign a number to represent some property. So for example, we might have sex, right? Males and females. And we might say that a female is a 1 and a male is a 2. And so in that case, you can't really do math, right? A 1 plus a 2 doesn't make sense, right? These are just numbers that represent categories. So another example could be ethnicity, eye color. A key way to distinguish this is if you can do math on it, then it's going to be a quantitative variable. If it's just a number assigned to some kind of abstract category or word or picture or symbol, this is going to be qualitative data. So here are some additional examples, right? So quantitative data might be your score on an exam, the weight of a person, the shoe size of a person. We can do math on this. Qualitative data might be assigning a 1 to John, a 2 to Patricia, a 3 to Mary. And in that case, adding those up, dividing them, subtracting them, it doesn't make any sense. We can assign the smell. We can categorize smell and assign numbers to different levels of smell. Or color. We could say red is 1, green is 2. But so this is the primary distinction. So another way that you can think about whether it's quantitative or qualitative is think about what the data would look like if you were recording it, right? So if you went out and you ask people their weight, right, you're going to have person 1 weighs 140. Person 2 weighs 137. How much do they both weigh? Well, you can just add those numbers up and get 277. And so this is a quantitative variable. What about hair color, though, right? If you see, we could say, okay, person 1 had hair color 1, and hair color 1 corresponds to blonde. So person 1 had blonde hair. Right? This is a qualitative variable. At the same time, you can represent the same type of data as qualitative or quantitative oftentimes, right? So if we're looking at the support for a candidate, well, it could be looked at in a binary fashion, yes, I support this candidate, or no, I don't, and we just report 1 or 0 for each person's response. So this is going to be an example of qualitative data, right? But we can also represent it in terms of percentage, right? Where we look at the percentage of people in a given county, and that, in that case, that's going to be a quantitative data. So we can further split this down. Quantitative data can be discrete or it can be continuous. So a discrete variable is a variable that consists of isolated numbers that are separated by gaps. In other words, values between adjacent units are not possible. So, for example, I could say number of children, right? Well, we can have 1 and we can have 2, but you cannot have 1.5 children. If I ask you, how many countries have you visited? You can't have visited 3.33 countries, right? It's either 1 or 2 or 3 and so on. So this is a discrete variable. Again, discrete variables consist of isolated numbers that are separated by gaps. A continuous variable is a variable that can assume any value, at least in theory. So in other words, there's an infinite number of values in between adjacent units. For example, I could say that weight would be an example of a continuous variable. How much do you weigh? I could say I weigh, 140.6593276654 pounds, right? You could look at the duration in time, and you can break time down into smaller and smaller units, and even in between seconds. We have milliseconds, right? And so this is an example of a continuous measure. The key difference is that continuous measures have an infinity of numbers in between each number. Now, we can see here, right? Here is an example of the WOMAC. The WOMAC is a commonly used measure of arthritis, right? And it asks people, basically the amount of activities that they engage in. And so you can see at the top, there is a discrete measure of on the WOMAC, right? So they're asked, how much they have pain when they're walking, right? And they have 0, 1, 2, 3, and 4. There is no 3.5, right? There's no 3.55. It's either a 0, 1, 2, 3, or 4. Now, this is in contrast to the visual analog scale that is depicted below, right? So here they're asked, how much pain do you have? And they just make an X somewhere on the scale. And it's up to us to measure it and figure out precisely where they fall. Now, continuous variables have upper and lower real limits. These are like bounds around which we contain the target value of interest. So let's look at this scale, right? So this is a continuous measure, and the upper and lower real limit is going to be the values above and below the recorded value by the half of the smallest measuring unit of the scale. That's kind of a mouthful. But basically, if our scale measures in units of 1 and we had 1 pound, it's going to be, the lower limit is going to be minus 0.5 and the upper limit is going to be plus 0.5 of our recorded value. So the upper and lower real limits of a value of 1 for a scale that has a measurement of 1 is going to be 0.5 to 1.5. So let's do another example of an upper and lower real limit. So let's say on the WOMAC, your pain score is 3.4 centimeters. That's what it was measured. And the smallest unit of measurement on the ruler is 0.1 centimeters. Well, 0.1, that means that we need to subtract, we need to figure out what half that measurement unit is, which is going to be 0.05. And then we subtract it from the recorded value of 3.4, and then we add it to the recorded value of 3.4. Right? So this is going to give us 3.35 and 3.45. 3.35 being the lower real limit, 3.45 being the upper real limit. Okay, and the final topic that I want to go into, which is tremendously important for this lecture, is the levels of measurement for a variable. So levels of measurement are properties of a variable and how it's measured that kind of build on each other in terms of the amount of information they carry. So we'll start with a nominal variable. A nominal variable is just a name assigned with a value assigned to it. So I might say blue eyes are 1, green eyes are 2, right? And so nominal variables are inherently qualitative, but they basically just indicate belonging to a certain group or category. So I could ask you, have you been diagnosed with major depression? Yes or no, right? This is going to be a nominal variable. You're just assigning yes to 1 and 0 to no. So the important thing is a nominal variable carries the lowest amount of information. Ordinal variables indicate a rank order. So we could say if you were participating in a race and you got first place, well, first place is going to be the shortest time. Second place is going to be the second shortest time. Third place is going to be the third shortest time, and so on. Most assessments in psychology are technically considered ordinal variables. So another example would be medals in the Olympics, right? Gold, silver, bronze. There is an inherent order. Gold is higher than silver, which is higher than bronze. However, the limitation of ordinal variables is that you can't assume that there's equal units between each value. So in other words, if I was in a race, first place could have just been, finished 10 minutes before the second place. But second place and third place might have finished seconds between each other. And so the distance between the units cannot be assumed to be equivalent. And for this reason, we're not able to really do math on ordinal variables. Now, if we make it so that the values are equal intervals between units, that's an interval variable. So you can see here that it builds. Each level of measurement adds some new property that it carries more information about the variable. So interval variables have proportionate intervals between their values. So an example of an interval variable would be temperature in Fahrenheit, right? So we have 80 degrees, the difference between 80 and 90 degrees is the same as the difference between 90 and 100 degrees. So we have equal intervals between units, but there's one thing that's missing. So, and that is that the value 0 means 0. So in the case of temperature in Fahrenheit, an interval variable, does a temperature of 0 mean that there's no temperature? No, it doesn't. A value of 0 is arbitrary in an interval variable. It can't be assumed that 0 means a lack of or nothing. And so the next level of measurement is a ratio level of measurement. So a ratio level of measurement can accommodate an absolute 0. 0 means 0. So an example of this would be temperature in the Kelvin scale, where a 0 value would mean a 0 Kelvin means no temperature, right? And another example of a ratio variable would be feet traveled, right? So if you went on a walk and we wanted to know how many feet did you travel, if you traveled 0 feet, that means you didn't go anywhere, right? So the 0 point actually means something here. Reaction time would be another example of a ratio variable. So the key thing here is nominal and ordinal variables. These are going to be qualitative. We don't do math on those. Interval and ratio variables, we can do math on. And the key distinction, again, between interval and ratio is that a ratio variable has a meaningful 0 point that indicates there's a lack of or nothing. So let's see if we can pick out the level of measurement for hypothetical grade at the end of the course. So say you've got a final percent grade of 94.5. Well, what level of measurement would that be? So let's think. Is 94.5, are there equal values between units? Right? Is the difference between 93 and 94 the same as the difference between 94 and 95? I would hope so, right? Certainly. So we can assume that it's interval. Now, does it have a meaningful 0 point? Does a grade of 0 mean you scored no points? Yes, right? So therefore, final course percent grade is going to be a ratio variable. It has a meaningful 0 and equal distance between units. Okay, a final course grade of A. Well, certainly, and we're assigning a letter to a value, so it's going to be nominal in that sense, but it also carries an inherent sense of order. So is the difference between A and B the same as the difference between B and C? Yeah. But what about F? Right? So F is much bigger. So therefore, it doesn't meet the interval requirement. It's an ordinal variable. What about passing the class? Pass or fail? So this is going to be nominal. There's only two measures here. What about Michelle getting a higher grade than Michael? Well, we don't know the difference between their grades, right? This is going to be an ordinal variable because all we know is that there's an inherent sense of order between the two grades, with Michelle doing better than Michael. Okay, so let's look at a example, just a common measure used in psychology. So this is the Center for Epidemiological Studies depression scale, commonly used depression scale, where people are asked to indicate their symptoms over the last week. So what level of measurement is this? Let's look at how it's scored, right? So people indicate on their response to, how frequently they have these symptoms, and then we add them all up and get a total, and then we can basically see if you're this point or higher, you're considered depressed. If you're not that high, you're not considered depressed. But the score, what is the score? Is it nominal, ordinal, interval, or ratio? So it's tricky, right? Can we assume that there is equal units between a value of, 1, 2, 3, and 4? I'm going to leave this one for you to reflect on, and we'll discuss it in the next lecture. For now, I appreciate you taking the time to get to the end of the second lecture in this class. I hope it was helpful and contributed to your learning over and above what was presented in the textbook. And I hope you have a great remainder of your day, and I will see you in the next class with lecture number 3. Okay, see ya.